Prove the identity tangent squared theta times cotangent squared theta minus cosine squared theta equals just cosine squared theta. So I would say that the left side is definitely the more difficult side on this one. So I'm going to start out by looking at the tangent squared theta. Tangent squared theta and cotangent squared theta are very similar. Tangent is sine over cosine. And I'm going to distribute that into this set of parentheses. Well, cotangent squared theta is the same as cosine squared theta over sine squared theta, and you'll hopefully see what's going on there before we multiply it out, minus just cosine squared theta. And so when I distribute this, sine squared over cosine squared times cosine squared over sine squared, everything's going to cancel out on that. The sine up here will cancel with the sine down there. And the cosine squared will cancel with the cosine squared down there, leaving just 1. And then I will have to take sine squared theta, cosine squared theta times negative cosine squared theta. So it's still there, but the cosine squared theta will cancel with this negative cosine squared theta, which will leave us just with sine squared theta, or negative sine squared theta. And 1 minus sine squared theta, remember, equals cosine squared theta, which is exactly what I'm trying to get it equal to. So cosine squared theta equals cosine squared theta, and I have proven that identity. Prove the identity cosine squared theta secant theta cosecant theta equals cotangent theta. Well, the first thing I see on this one is that cosine and secant are reciprocal functions of each other. So if I were to rewrite the secant as 1 over cosine theta, cosine theta will cancel out with one of the cosines on cosine squared theta, so that will just leave us with cosine theta cosecant theta. And let's see, we know that cosecant equals 1 over the sine. So if I change cosecant to cosine theta times 1 over sine theta. If I take cosine theta times 1 over sine theta, that leaves me with just cosine theta over sine theta. And what does cosine over sine equal? It equals cotangent theta, which is what I'm trying to prove it equal to up here. So that is proven. And then sometimes there's just no way around it. It is the easier to transform each side of the equation separately into a common form. Following suggestions may be helpful to verify trig identities. Substitute one or more basic trig identities to simplify the expression. Factor or multiply as necessary. And you may have to multiply both the numerator and the denominator by the same trig expression, kind of like we saw in example 1. Write each side of the identity in terms of sine and cosine only, then simplify each side as much as possible. So going back to your cheat sheet, you can notice that there are a lot of things can be rewritten in terms of sine and cosine. Both tangent and cotangent can be written as terms of sine and cosine. Secant and cosecant are the reciprocal functions of sine and cosine. You can see that right here. There's secant and there is cosecant actually right there. Pythagorean identities. Even if you have tangent squared theta equals secant squared theta, then later on you can change those in terms of sine and cosine. So trying to get as many things in terms of sine and cosine is really helpful. And then finally, the properties of equality do not apply to identities as with equations. Do not perform operations to the quantities of each side of an unverified identity, because sometimes they just won't be able to be verified or shown that it truly is an identity. So question 3 says verify that cosecant squared theta minus cosine squared theta equals cotangent theta. Tangent theta is an identity. So if it says to verify that, it is telling you that it most definitely is an identity. So you will find a way to prove it. So on the right side of the equation, I have cotangent theta and tangent theta. Cotangent and tangent, right here and right here, those are reciprocal functions of each other. And when you take a reciprocal times itself, or times a function times its reciprocal, you get just one. Because remember, cotangent is the same as sine over cosine. Excuse me, tangent is sine over cosine. Cotangent is cosine over sine. Cosines would cancel out, sines would cancel out, leaving you just with 1. So I'll go ahead and just substitute that side with a 1. The right side of the equation, I see cosecant squared theta minus cotangent squared theta. And let's see. Cosecant squared theta, as I look into Pythagorean identities, right here, it says cotangent squared theta plus 1 equals cosecant squared theta. I could replace cosecant squared theta with that. So that would be cotangent squared theta plus 1. So cosecant squared theta has been replaced with cotangent squared theta plus 1. Minus, here's the cotangent squared theta, and notice that I have a positive cotangent squared theta and a negative cotangent squared theta. They cancel each other out, leaving me with just 1 equals 1, which means I have just verified that identity.